magumu, lakini never give up. Saka nimeteseka, aso nimeaso, wala leo umenifungulia, wala mimi sitolia. Saka nimeteseka, aso nimeaso, wala leo umenifungulia, wala mimi sitolia. I want to take you through classification of substances from 1 topic 2. Majorly I want to measure on mixtures. Here we need to know the types of mixtures that we have and how to separate them, so that when you are asked methods of separation, you are able to answer that question. So I want to just take you through some types of mixtures. You know how to define a mixture. We have a solid mixture, and the solid mixture example, we have iron and sulfur, sand and beans. That mixture, maize and beans. This one is a solid mixture. How do we separate this? We can separate either by magnetism. This one of them must be a magnetic material, so that they can be attracted and leaving the other. For example, iron is a magnetic material, so it can be attracted by a magnet, and sulfur will remain. Maize and beans, we can use picking. We can pick the maize and leave the beans. We have separated. We have sieving. We sieve our maize when we go to the portion mill, so you sieve. So that's a type of. And then finally we have sublimation. Sublimation is used to separate a solid mixture. You should know substance which is sublime. For example, we have anhydrous iron 2 chloride, which sublimes, aluminium chloride, which sublimes. We have benzoic acid, which sublimes, and then we have dry ice, which is solid carbon 4 oxide. So once you have known the substance which sublimes, when you find a question, you will find it very easy to know. So you should know substances which sublime very much. You should have them in your mind. And then we have another mixture which is solid liquid mixture. Here we have where the solid is soluble, like salt. Sodium chloride is soluble in water. So this one we call it soluble. Sodium chloride plus water. How can we separate that? We can use evaporation. So we will evaporate, and then finally we will obtain our solid sodium chloride. We have those that are insoluble, solid, liquid, insoluble. For example, we can have like sand plus water, right? This one we will have to decant or do what we call filtration. In filtration, you should know the solid which remains on the filter paper, we call it the residue. And the solution which passes through the filter paper, we call it the filtrate. So these are the terms you need to be aware of. So we have the filtrate and the residue. The residue is the solid which remains after filtration. We have liquid mixture. Liquid mixture, we have two types. Type 1 is miscible, the one that dissolves to form a uniform color. We call it a homogeneous mixture. It forms an homogeneous mixture. So if it forms an homogeneous mixture, then we have to do fractional distillation. And you should know that liquids which are separated by fractional distillation, they must have different boiling points. Yes. So they have different boiling points. That's why they are able to be separated by fractional distillation. We have those mixtures which we call immiscible. Immiscible, it means that it does not dissolve in water. When you mix them in water, they don't form an homogeneous solution or a mixture. They form an heterogeneous solution, heterogeneous. Therefore, an example is water, and an example is water. We have water and paraffin or kerosene. That one is immiscible. So how can we separate that? We use a separating funnel. We can use a separating funnel to obtain that one. And then finally, next we have the solvent extraction, which you must know. Solvent extraction. This is the method that is used to separate or to obtain substances from for example, we can obtain oil from seeds. We can obtain herb or medicine from plants by using solvent extraction. Here, you need to know the solvents that are used. We have propanol, we have ethanol as the solvents that are used there, and you should know now the procedure. You need to crush first, and then you follow the procedure that we are going to talk about. Next one, you should know the applications of solvent extraction. You should know them. So let me take you straight now to the question. A mixture contains ammonium chloride, copper 2 oxide, and sodium chloride. Describe how each of the substances can be obtained from the mixture. So, you see we have a mixture of these three compounds or substances. Now, first, something you need to know is that check on each of them. Which one, is there any one of them which can suprime? Is there any one of them that dissolves in water or dissolves? So you check on the solubility, you check on which one is insoluble in water. Like now, ammonium chloride, we know is a supplement. It suprimes when heated. Therefore, we are going to start with sublimation to separate ammonium chloride. We know that copper 2 oxide is insoluble in water, but we know sodium chloride is soluble in water. Therefore, after sublimation, we are going to dissolve the remaining mixture in water, whereby sodium chloride is going to dissolve and the copper 2 oxide is not going to do what? To dissolve. It will remain insoluble. The next thing now we will do, how will we separate the two? We will filter. After that, this one will remain as a residue, and this one will be collected as a filtrate. And then this filtrate, to obtain sodium chloride crystals, we need to evaporate. So that's why it is important you to know the methods of separation all of them. So first what we do is to place the mixture. Place the mixture in a beaker. Place the mixture in a beaker. Then cover the beaker with a glass watch. A glass watch containing cold water. Containing cold water. The reason why we have cold water in this one is that when the ammonium chloride suprimes, it will be cooled here. It will find water which is cold, and it will be collected on the bottom of this glass watch. So heat the mixture. Heat the mixture until no further change. So ammonium chloride sublimes and condenses on the cold water, on the bottom of the watch glass. So far we have separated ammonium chloride. Now we are remaining with copper 2 oxide and sodium chloride. So the next, now you add water. Add water to the mixture, to the remaining mixture in the beaker. Of course, it should be distilled water. Add distilled water to the remaining mixture. Then what will happen? Sodium chloride dissolves and copper 2 oxide does not. Copper 2 oxide does not. Then now the next thing we do is filtration. So filter the mixture to obtain CuO, copper 2 oxide, as the residue and sodium chloride as the filtrate. Now we have the filtrate. The next thing we do is to evaporate, because what we want is sodium chloride crystals. Evaporate the filtrate. Evaporate the filtrate to saturation. And allow crystals to form. Then you will dry the crystals between filter papers. So far we have obtained all that we wanted to obtain. We have done everything that was required. Explain how you would obtain sodium carbonate from a mixture of lead carbonate and sodium carbonate. Now we have a mixture of lead carbonate and sodium carbonate. We are required to obtain sodium carbonate from that mixture. First question you should ask yourself is whether this is soluble or not. Is it soluble or not? Is this one soluble in water or not? Fine. We know that lead, all carbonates are insoluble, except that of potassium, sodium, and ammonium carbonate. So it means lead carbonate is insoluble. Lead carbonate is insoluble. Sodium carbonate is soluble in water. Once you have identified that, now the next thing you do, you will add water to the mixture, where chloride is going to dissolve and this one is not going to dissolve. From there, you will do filtration. This one, sodium carbonate, is going to be obtained as a filtrate, and lead carbonate is going to remain as the residue. You will evaporate the filtrate and obtain sodium carbonate salt. So add water, distilled water, add distilled water to the mixture in a beaker. Add distilled water to the mixture in a beaker. Filter. Okay, we can stir until all the sodium carbonate dissolves. Filter the mixture. Filter the mixture to obtain lead carbonate as the residue and sodium carbonate as solution. Sodium carbonate solution as the filtrate. Evaporate the filtrate. evaporate the filtrate to saturation, and allow the saturated solution to form crystals. So once the crystals has been formed, you dry them between filter papers. Dry the crystals between filter papers. So far you have now obtained the sodium carbonate from the mixture that you were given. Describe an experiment procedure that can be used to extract oil from nut seeds. Remember, oil can be extracted from nut seeds, from sunflower seeds, from ground nuts. So it depends the seeds you have been given. Now this one is the nuts. So remember this one, this is the solvent extraction. So the first thing you need to know is that these seeds has to be crushed, and in the laboratory what we use to crush is the pestle and the mortar. So you say that crush and grind the nut seeds using a pestle and mortar. You grind the nut seeds using the pestle and the mortar. After that, now you add the suitable solvent. You can use propanol, you can use ethanol. So add propanol and stir to dissolve oil. Remember, oil is soluble in propanol, ethanol, but it is not soluble in water. So that is why we don't use the solvent water here. We use propanol, the organic solvents, to dissolve oil. After that, you leave the solution or the mixture solution in the sun for propanol to evaporate, leaving the oil. So that's the procedure that you need to describe whenever you have realized that the question is a solvent extraction method or kind of question. That is how you will describe. Explain how students can establish whether a liquid sample extracted from plants is pure or not. So remember, in this topic's classification, simple classification, for you to check whether a substance is pure, you use the melting point and the boiling point. Remember, pure substances has got sharp boiling point and sharp melting point. So you will ask the students to measure. The students have to measure the melting point and the boiling point of the sample. They have to measure. If the sample has a sharp a sharp melting point and a boiling point. Then the liquid sample is pure. The liquid sample is pure. Thank you for today.